to discuss some characteristics of both pumps, both types. What is the pump similarities, hydraulic and mechanical end, regardless of the pump of the type? If you are going to speak about the hydraulic end, yes, hydraulic end, the head produced, the head, what is the head need for each type of the pump? The head requested by the pump is differential pressure difference over the specific gravity. So then you got how amount of head needed from the pump. This is rely on the system and the fluid characteristics. And this difference pressure is the charge pressure minus the section pressure, static one, gauge pressure. And what is the brake horsepower? Brake horsepower absorbed by the pump, how much power have to be delivered to the pump to produce this, to move the fluid and produce the differential pressure. You can calculate the brake horsepower equation from is the head times the flow, the GPM, times the specific gravity over pump efficiency. And the pump efficiency coming from the each supplier data sheet and the curve. In the mechanical end, you can see that each type of the pump have a casing. It's called the casing in the centrifugal, it calls cylinder in the reciprocating. And also it must have a seals, mechanical seal or backing. Mechanical seal usually in the centrifugal and the backing. So centrifugal use the mechanical seal and the backing. Screw rotary use the mechanical seal or backing. Reciprocating used only backing. And also each part or each type of the pump must have a bearing, radial bearing, and some of them have a thrust bearing. So we can see this is low flow high pressure. Low flow high pressure is reciprocating. In centrifugal means high flow and less pressure, the centrifugal, and in between the rotary. And the order of the selection will be centrifugal, rotary, reciprocating, with a certain ranges and limits. Okay. What is the main difference between positive displacement and dynamic? The positive displacement is increasing pressure by operating on a fixed volume in confined space. But the dynamic is increases pressure by using rotary blades to increase fluid velocity, then changing the velocity or convert the velocity in terms of the pressure, static pressure 1. Okay, that's why the change characteristics curve of this type of the pump positive displacement is like vertical line. So the flow rate is more or less is approximately constant. The flow rate produced is constant, depending on the cylinder dimension and operating speed. While can be delivered more pressures, more head. In the centrifugal, no. In the centrifugal, you can see the flow can be changed along the curve, while the produced head is not too much different. You mean this flow, the head range from the last point, the end point of the curve to the starting point of the curve is about 30-40%. This curve, for sure, you cannot operate the pump at this point or at this point. There is a certain range, minimum continuous stable flow, and the choke flow, the pump operating from this point to this point, and this change of the head from this point to this point is about 30-40%. It's not too much. The types of the positive displacement is the screw gear reciprocating. The type of the dynamic is the centrifugal and the axial. What are the characteristics? The characteristics of the positive displacement is the pump is a constant volume, as we can see, constant volume, is variable differential head. Yes, can deliver this head and this head as this head, as long as there is a sufficient power in the driver. The pump is relatively insensitive to the liquid properties. You mean is a pump is handling density of 1000 kg per meter cube. Then the fluid is changed the density to 500 kg per meter cube. There is no change. It will produce the same amount of the flow. the same amount of the flow, regardless of the change in density. And any pressure you need will deliver, as long as there is sufficient power. Relatively insensitive to the system, it changes. If you are going to move the fluid, for example, in the building from the first floor, in terms of delivering the water, the pumping is installed in the ground floor, and you are going to move the fluid, move the water from the ground level to the 10th floor. After a certain time, you need to extend the operation of the pump from the 10th floor to 30, the door number 30, the floor number 30. Yes, it can, as long as there's sufficient power. But the problem is the pump is not self-limiting. You mean if you're closing the charge valve downstream the pump, the pressure will be increased. And the piping will be broken. Because usually the pump is more stiff than the piping. The pressure rating of the pump is higher than the piping and the devices downstream the pump. So you have to install pressure relief valve to make the pump limiting. This pump is not self-limiting due to the characteristic of the curve, the performance curve of the pump, how the flow is changed with the head. Okay, what is the dynamic characteristics of the centrifugal pump? Centrifugal pump is variable volume flow. Yes, you can close the valve partially and getting small amount of water and increase, open the valve, getting more flow, closing the valve, getting less flow. So it's a variable volume. Yeah, you can see this here. This is a flow range. Constant differential head, approximate. Yes, this approximate, because as I mentioned, the difference between this point and this point is about 30-40%. So it is likely constant differential head. Sensitive to liquid properties, yes, because it accelerates the flow. So the flow, if this flow have a higher viscosity, having a higher density, yes, it cannot easy to the curve will be dropped down or higher, move higher or drop down, because the fluid will be have a more weight, more dense, or the shear forces between the blades and the fluid become more. This means these losses is coming more if I'm speaking about the high viscosity. This pump is self-limit. Yes, for sure, it's sensitive to system change. Yes, why is okay? If you are going to operate the pump in the building at the ground level, and this pump is probably sized to deliver the flow up to the 10th floor in the building. If you are going to operate this pump to deliver the flow at the floor number 30, it cannot. Why? Because the head needed to raise the water or to deliver the water to the floor number 30 is for example 30 meters. And the pump curve that is sized for the 10th floor, the range of the head maximum is 15 meters. So it cannot deliver. You need a higher impeller. You need a high speed, another curve. You need a higher curve. You need a higher curve reaching the head to the 30 meter, 35, 40 meter. So this is very sensitive to system changes. This pump is self-limiting, yes, because if you close downstream the pump, if you close the valve downstream the pump, this is the amount of head increased. There is no more. So you properly design the system piping downstream the pump to this value, short of value. Okay. Again, what is the advantage and disadvantage? The advantage of the centrifugal pump is the variable capacity control over operating range at constant speed. The centrifugal pump can handle liquid containing catalyst, dirt solids, the centrifugal pump can pump liquid with a poor lubricity, because we don't need lubrication. No problem about that. The weight, size, and initial cost and installed cost is lower than positive displacement with the same hydraulic condition. If you have a choice between positive displacement and centrifugal, that means the both pump types are existing in the same range of the flow and head. So for sure you are going to use and to install both centrifugal. You order centrifugal, you purchase centrifugal. Why? Because its weight, its size, initial cost, installed cost is lower than the positive displacement. Okay? There is no wrapping parts, minimum wear, higher availability for sure. Doesn't normally request overpressure protection over operating range at constant speed because it's self-limiting. What is the disadvantage? The disadvantage is the flow rate is affected by specific gravity, as we will see later on. Viscosity affects the performance, yes, we will see also. Request priming, we usually not design the system for to need priming. Usually make the pump level, the liquid level above the pump center line. Suction head, not suction lift. Develop limited head over operating range at constant speed. Low to moderate efficiencies, yes, the efficiencies about from 10% maybe up to 50-60%. Positive displacement pumps have no limited to delivery pressure for a given capacity, no limited. Can produce 1 bar, 10 bar, 30 bar, 40 bar, whatever, as long as there's sufficient power. Can handle high viscosity liquids efficiently, yes. This has a superiority over the centrifugal. The limitation of centrifugal pumps is 180 centibars. If you are going to handle liquid with viscosity more than 180 centibars, is not practically in the market. You cannot get a centrifugal pump in the market. You have to specify positive displacement, no centrifugal. If the viscosity of the liquid more than 180, you must specify positive displacement pumps, not dynamic type or centrifugal type, because the positive displacement can handle a high viscosity liquid efficiently. A higher efficiency than centrifugal, yes, usually is coming from 45-50% up to 80. Flow rate is not significantly affected by specific gravity, yes. Disadvantage of the pump is request over pressure protection, pressure relief valve. Flow control, if we need to control the flow, how is done? Either by speed or bypass, except hydraulic diaphragm pump. They can change the stroke length. Pulsation associated with reciprocating positive displacement, and you have to install a pulsation damper at the discharge. This is the same. Okay, let's see some of design analysis. Okay, since the characteristic of centrifugal pumps is to add energy to the liquid by working the liquid with rotating blades, velocity plays an important part in the makeup of these pump characteristics. Anything that will result in velocity change at the tip of the blade will result in a change in the produced head. If the velocity changes, then the produced head will be changed. How it will change it, and the corresponding flow change for sure. This type of the pump will be extremely sensitive to the system resistance change or specific gravity. As we see from the equation of the head, system head is delta B differential pressure over the specific gravity. So for the same differential pressure, if the liquid density is changed, become more dense, a higher density, with the same numerator, the denominator is changed, will become higher. This means the system need head more or less. If the density is increased and the differential pressure is the same, then increasing the density will lead to decreasing the head. Decreasing the head, system head, mean the pump to respond to this different liquid density the point will going to right side, because the system now need less head because it handle a high density. Okay, vice versa. If the system going to handle low density liquid with the same differential pressure, the system need more head, and this cannot be achieved by the centrifugal pump unless the pump operating at low flow to produce this increasing head. So if the density is decreased, you are going to operate at low flow. If the density is increased, you are going to operate at a higher flow, mean low head or a high head. This is the limitation. So the system, since the increase in system resistance requirements will force the pump to operate at reduced flow rate. Okay. What about the positive displacement? Okay, positive displacement will produce nearly constant flow while continuing adding head to the liquid or energy, providing sufficient power is available. And the pump and the drive system is designed to meet this objective. The positive displacement pump will be relatively insensitive to both system change and specific gravity. If you are going to close the valve, then the pump, instead of the system needs this head, will increase the head. This means the pump will deliver this head. Yes, it can. And the flow change nothing, can be neglected. If the density is increasing, this means the head needed by the system is less, so the pump will operate here. This density is decreased, so the system head is a high, so the pump will operate here, so it can produce any head requested. What about the viscosity? The effect of increased viscosity in centrifugal pump performance is significant. Yes, it's significant. The head curve is dropped down. The pump will deliver low flow, low head, and less efficient, i.e. more power. The higher viscosity increases the friction losses, hence the power. In addition, the head capacity curve drop off as the viscosity increased. Yes, as the viscosity increase, the curve will be drop off. As the same pump, it deliver viscosity of 1 centibars like water. If you change the liquid and produce 100 meter cube and produced 100 meter, okay? If you change the liquid with a higher viscosity liquid, for example 100 centibars dynamic viscosity, so this 100 meter cube will become 80 meter cube per hour, and this 100 meter will become 70 meter. The pump was absorbing 100 kilowatt. Now it will absorb how much power? It would become 150, 200 kilowatt. Yes. So the absorbed power will be much higher, and the flow and the head will be less. Okay. So the practical market viscosity limitation of the centrifugal is 100 to 230 centibars. What about the positive displacement? No, the positive displacement have different characteristics. Viscosity does impact on the performance characteristic of the positive displacement pumps. However, the effect is not great as for kinetic. As the viscosity of the fluid handled by reciprocating pump is increased, for example, if I'm going to speak about the reciprocating, the valve suction is affected. A higher valve leakage occurs at constant pump speed, resulting in lower volumetric efficiency. To maintain the same volumetric efficiency, pump speed will have to be reduced as the viscosity increased. Additional effect on the reciprocating pump is increased head loss through the suction valve and the port, thus increased pump emphasis. On other hand, rotary pump. Rotary pump performance is also affected by changes of low viscosity. Capacity is reduced by decreasing viscosity. This occurs because of increased leakage through the internal clearance, resulting in a high slip factor. As the viscosity is increased, the capacity curve approaches the theoretical displacement. So, in reciprocating, if the viscosity is increased, the flow a little bit decreased, and the losses increased for sure for MPSH. For the rotary pump, if the viscosity is increased, great, the flow will be more, approaches the theoretical one. Okay, so this is the losses in positive displacement. The changes is not too much with the variation of the viscosity. Okay, that's all. Thank you for all. Thank you for time. This is second part of our course. Hope you get you make use of this all knowledge and you practice all this information, and waiting you in the next part of our course, part 3. Thank you. Bye bye.